For centuries, we've wrapped the concept of love in all this beautiful poetry, right? We assign it to the heart, we paint it with these sweeping romantic metaphors, and basically, we treat it like it's pure magic. But the reality? Well, the reality is actually much darker, incredibly mysterious, and frankly, it's a bit of a biological thriller. Welcome to today's Explainer. We're going to completely shatter that poetic illusion of romance to reveal the raw biological reality of what's actually happening inside your head when you fall in and out of love. You know, there's a saying that love is an intense roller coaster of emotions and brain activity. And it's so true. We tend to think of love as this warm, comforting blanket. But neurologically speaking, it is a high-speed, completely chaotic ride from the very first spark of a gaze across the room, all the way to the last tear of a breakup. Your experience is entirely dictated by this relentless, invisible symphony of neurochemicals. So, you might be wondering, what exactly does the brain have to do with all of this? Well, the answer is absolutely everything. Let's just dive straight into this biological investigation. Because honestly, once you see how your brain is pulling the strings on your deepest feelings, you are literally never going to look at romance the exact same way again. Section 1. The neurochemical hijacked. Okay, think of this as the very beginning of our thriller. You're daydreaming, you want to spend absolutely every waking second with this new person. And why? Because your brain is being completely taken over. It all starts right here, in a tiny region called the ventral tegmental area, or the VTA for short. This is the ultimate reward processing and motivation hub of your brain. And when you first begin falling for someone, your VTA just kicks into absolute overdrive. It's the engine room of that intense, super passionate stage of early love, and it's basically initiating a massive hijack of your normal baseline state. But here's what's truly fascinating. Look at what else activates the VTA. Sure, it fires when you eat a sweet treat or finally quench a really deep thirst, but shockingly, it also fires when someone takes drugs of abuse. So when people say early love feels intoxicating, that's not just a cute metaphor. The stark reality here is that falling in love fires the exact same brain region as taking a hit of a highly addictive drug. In all of that VTA activation, it releases a huge flood of something you've probably heard of before, dopamine, the famous feel-good neurotransmitter. Dopamine acts as your brain's ultimate reward signal. It's what makes love feel so wildly euphoric. But more importantly, it relentlessly teaches your brain to repeat the behavior. It's literally drawing you toward your new partner, conditioning you in anticipation of getting that same incredible high over and over again. But while your VTA is busy flooding your entire system with dopamine, what exactly is happening to your logic? Let's take a look at the prefrontal cortex. Now, this is the brain's cognitive center. It's the area responsible for critical thought, for passing judgment, and, for actually keeping you grounded in reality. And this brilliantly illustrates why we act so, frankly, foolishly when we're falling in love. During this intense infatuation stage, some individuals show a literal, measurable decrease in activity in the prefrontal cortex. Infatuation essentially shuts down your critical thinking, it totally suspends your judgment, so those rose-colored glasses everyone says you're wearing, that is not just a saying, it's a temporary biological deficit. It is the exact reason why it is so incredibly hard to see any faults whatsoever in your perfect new partner. Section 2. The chemistry of pair bonding. Now, that first stage, that intense, dopamine-fueled roller coaster we just talked about, that typically only lasts for a few months. Eventually, the ride has to slow down. We transition from stage 1 infatuation into stage 2 attachment, which is also known as compassionate love. The fast-paced, dizzying high slowly gives way to a deeper commitment, and this is driven by a completely different set of neurochemicals taking the wheel. Enter the pair bonding hormones, oxytocin and vasopressin. These chemicals signal deep trust and feelings of social support, forging an intense, almost addiction-like attachment to your partner. It's a deeply powerful bond, and it's driven by the exact same hormones that are literally responsible for gluing families and lifelong friendships together. So the really crucial point here is how this chemical interaction actually changes how you feel. Oxytocin can literally inhibit the release of stress hormones in your body. So, as that initial early love suspension of judgment fades and your rose-colored glasses finally lose their tint, this new stable chemical profile replaces it with an honest, deep understanding. Spending time with your loved one becomes profoundly relaxing. Their physical presence literally blocks stress from building up. They become your absolute sanctuary. Section 3. The agony of heartbreak. But what happens when that sanctuary is destroyed? As a relationship ends, the brain plunges into a brutal,
brutal state of neurochemical withdrawal. To really understand this agony, we have to look at the insular cortex. This is a region of the brain that processes pain. But here is the mind-blowing fact of the day. The insular cortex processes both literal physical pain, like, say, spraining your ankle, and social pain, like the deep feelings of rejection. So to your brain, the pain of a bad breakup is virtually indistinguishable from a severe physical injury.
Let's just step through this agonizing biological cycle for a second. First, the insular cortex registers the romantic rejection as literal physical pain. Ouch. Second, remember our old friend, the VTA? Well, it fires right back up. When you stumble across a photo of your ex, the VTA drives this desperate, overwhelming craving for them. It's exactly like an extreme hunger or a deep thirst. And finally, this whole emotional whirlwind triggers your body's alarm system, the stress axis, which leaves you feeling physically shaken, anxious, and completely restless. You are, biologically speaking, in active withdrawal.
And actually, this explains the phenomenon we have all probably wondered about. Why do our first loves hurt the absolute most? Well, adolescent heartbreak feels incredibly agonizing because the higher cortical regions, the parts of the brain that oversee logic, reasoning, and impulse control, they are still maturing. They're still making connections. The younger brain simply lacks the fully formed brakes needed to stop those overwhelming panicked distress signals.
Section 4. Rewiring for recovery.
Okay, take a deep breath because there is light at the end of the tunnel. You are not doomed to stay in a state of neurochemical withdrawal forever. The brain is incredibly resilient, and it has built-in mechanisms to eventually break the dependency. Over time, those higher cortical regions we just talked about, the ones responsible for rational reasoning, they finally step in. They start to assert control, actively pumping the brakes on all those distress and craving signals. Very slowly, your brain learns to quiet the alarm bells and regain its normal baseline equilibrium. And the best part is you can actively help this process along. You can safely hijack your own dopamine system to heal. The source data shows us that simple, everyday activities like exercising, spending quality time with friends, or honestly just listening to your absolute favorite song can tame that heartbreak stress response. Why? Because they trigger the release of that feel-good neurotransmitter, dopamine. It gives your brain the healthy, natural reward it's been desperately craving, completely bypassing the need for your lost partner. Given time and support, your brain will rewire and you will heal from even the most devastating heartbreak. But seeing it all laid out like this, it does leave us with a pretty profound question to chew on. Are your deepest, most intimate romantic feelings truly yours? Or are they just a beautiful, completely chaotic symphony of neurochemicals? It's definitely something to think about the next time you feel those butterflies in your stomach. Thanks so much for joining me on this